When the German Wehrmacht smashed across the western USSR in the summer of 1941, Soviet planners faced one brutal arithmetic problem. Most of the empire's heavy industry, its machine tools, rolling mills, foundries, and the skilled people who ran them, lay in the path of the invader. In the months before Barbarossa, the Soviet economy had been partially centralized and concentrated in the West. The bulk of aircraft plants, tank works, and metallurgical capacity clustered within a few hundred miles of the frontier. Lose those plants, and you did not merely lose a factory, you lost the ability to replenish weapons, to repair broken tanks, to manufacture engines and transmissions, the very industrial heartbeat of modern war. The solution the Soviet state chose was dramatic, almost surgical. Move the industry east, out of range of the Luftwaffe and the rapid blitzkrieg advance, and, if necessary, bury it under earth and rock until the danger passed. This was not a single program, but an operational doctrine: evacuation, dispersal, and sheltering, carried out at enormous speed and scale. Nearly 1,500 large factories and millions of pieces of equipment were packed, loaded on rail, and transported by the end of 1941. That decision, to move whole production systems rather than surrender them, is the first part of the story of how the Russians built tank production under cover. Why bury industry at all? Strategic bombing and mobile warfare had taught a lesson: exposed factories die. A Luftwaffe was already demonstrating that precision and area bombing could shut down large plants in short order. The Soviets, who did not have safe rear areas close enough to the front everywhere, therefore pursued two parallel protective strategies. The first was geographic: relocate. Whole plants, their tooling, and tens of thousands of workers were sent to the Urals, Siberia, and Central Asia, where rail lines and raw materials, coal, iron, and power existed. Cities like Chelyabinsk, Nizhny Tagil, Sverdlovsk, and Omsk became new industrial hubs almost overnight. The second strategy was structural and concealment-based, where suitable above-ground locations could not be established quickly, or where critical tooling needed extra protection from bombing. The authorities considered or used subterranean solutions, deep shelters, reinforced factories inside quarries or mines, and heavily protected production halls carved inside solid rock, used either to protect especially vulnerable processes, for example, critical machine tools, finishing shops, or engines awaiting testing, or to conceal the most strategically valuable production lines. The Soviet program blended these two streams. Tankograd is emblematic of the relocation success, while the use of buried or rock-cut spaces illustrates the survival-driven innovations in plant protection. Why focus on tanks? Because armored fighting vehicles were both the immediate lifeblood of the Red Army and the most politically sensitive product. The T-34 medium tank, simple by design but lethal on the battlefield, needed continuous production in numbers, not just prototypes or one-offs. To sustain the Red Army through 1941 to 1943 required hundreds of tanks per month. This meant welding shops, turret factories, guns and ballistic shops, heavy sight foundries for turrets and hulls, engine assembly lines, and transmission machining all had to be preserved or rebuilt. A single German air raid on a rolling mill or engine shop could produce months of downtime. Thus, tank production became a litmus test for industrial survival. Can you make armored vehicles even when your factory is threatened from the air or ground? The Soviet solution mixed quantity, evacuate and duplicate production at scale in safer areas, with quality of protection, shield critical lines underground or within strongly reinforced structures. The result, at least in many sectors, was an unglamorous but decisive triumph of logistics over blitzkrieg. To make sense of the underground tank factory label, you need to understand what Soviet planners meant by underground. They did not usually intend entire million-square-meter complexes hollowed from mountains like the German Mittelwerk. Instead, the common Soviet approach was pragmatic and hybrid. They repurposed existing subterranean cavities, mines and quarries, for protected workshops, constructed heavily reinforced bunkers and bomb-proof halls partially buried and roofed with earth and concrete, and integrated machine lines across both surface and subsurface layers. In other words, a single tank plant might be a composite, final assembly halls on the surface, while heat-sensitive machine tools, forgings, and testing stands were placed in underground spaces for protection. This approach conserved resources, excavation was expensive and time-consuming, and allowed rapid reorganization. It also meant that underground tank plant can legitimately describe a variety of configurations, from a single blast-proof engine shop under 10 meters of compacted earth to an assembly line running in a repurposed mine gallery. Where documented archaeological and archival sources exist, such hybrid solutions are the predominant pattern, rather than massive tunnel complexes dedicated solely to tanks. A second strategic motivation for subterranean work was deception and survivability against reconnaissance. The Germans' air intelligence and bomber fleet could locate and attack large industrial footprints, so reducing the visible signature of a plant by burying roofs, dispersing workshops across natural topography, or situating heavy forging and heat-producing activities underground lowered detection probability. Placing high-value machinery under rock also reduced the cascading vulnerability of critical path machines. If your primary crankshaft grinder is destroyed, you can't produce engines. If an engine shop is below surface in a bomb-proof hall, you can continue production while surface shops rebuild. This idea, protect the fulcrum of the production chain, is crucial to understanding why some Soviet tank production elements ended up undercover. It was less romantic than a secret city under a mountain, and more a rational allocation of protection resources where they mattered most. Finally, the strategic choice to shelter production was also political and organizational. Stalin's State Defense Committee, or GKO, and its network of ministries had prioritized the movement and protection of strategic industries. Orders to relocate were backed by rail requisitions, fuel allocations, and labor resettlement directives. Factory directors, machine tool experts, and literally thousands of tram cars and freight wagons were mobilized. The cost was enormous, in speed, in the roughness of initial production, and in hardship for workers, but the political will made it feasible. The result is the familiar paradox. The Soviets did not always build long, elegant underground factories. They did something arguably more effective under the circumstances. They dispersed, protected, and reconstituted production in the Urals and beyond, using underground spaces selectively to keep the critical heart of tank manufacture beating. The engineering story that follows, how they dug, wired, and kept welding machines humming under earth and stone, is where the industrial improvisation becomes most vivid.
If you press the historical record for a single emblematic example of wartime Russian tank industry survival, Chelyabinsk, Tankograd is the place to start. Within a year of evacuation orders, the Chelyabinsk cluster had taken in whole plants, reassembled presses and lathes on new foundations, and produced engine blocks, turrets, and entire hulls by the thousands. Its capacity surge was a study of improvisation. Temporary sheds and open-air welding stations worked alongside hastily completed reinforced shops. Where the risk of bombing remained acute or where certain processes were most vulnerable, high-precision grinding, boiling furnaces, or finishing, the plant managers placed those functions into protected halls or moved them into natural or excavated shelters. The result was not one giant underground cavern, but a layered factory system in which earth and rock provided real, measurable protection for the machines that mattered most. Tankograd's output statistics, thousands of tanks and tens of thousands of engines and parts during 1941 to 1945, quantify that success and show why the Soviet blend of relocation plus targeted sheltering worked. The decision to bury or partially buried tank production was not just about survival, it was about endurance. Once the Soviet government made the call to move and conceal critical industries, the question turned from why to how. How do you dig out enough space to house entire machine shops, foundries, and assembly lines? How do you power and ventilate them? How do you transport in raw materials and tanks out when your factory is under the ground? The answers were an engineering experiment conducted under fire, and the result was one of the most remarkable feats of wartime industrial organization ever achieved. To build an underground factory in wartime Russia,
The first and greatest constraint was time. Unlike the Germans, who began constructing vast subterranean complexes such as Mittelwerk or the Valentin U-boat bunker late in the war, the Soviets had to act immediately in the middle of the 1941-42 crisis when the Wehrmacht was still advancing. The clock was measured not in years, but in weeks. Every hour lost meant fewer tanks at the front. That urgency forced engineers to use what already existed, mines, quarries, and tunnels, rather than carve out entirely new chambers from virgin rock. Across the Urals in Siberia, abandoned ore mines and unfinished rail tunnels became the skeleton of hidden production sites. For instance, near Nizhny Tagil, one of the most important tank centers in the USSR, several early facilities were relocated into or next to iron ore mines. The area's geology, hard rock with good bearing strength, made it ideal for reinforcement. Instead of blasting out new space, workers adapted mining galleries by widening them and adding concrete ribs to support roof loads. The space wasn't beautiful, it was cramped, dark, and irregular. But the rock walls provided natural bomb resistance. Overhead, workers poured layers of sand and reinforced concrete where needed, sometimes adding an extra 5 or 10 meters of earth for insulation. When completed, these galleries were almost invisible from above, with only a handful of disguised entrances and ventilation shafts breaking the surface. The technical challenge wasn't only about digging, it was about creating a livable, functioning machine ecosystem underground. Air circulation was critical. In most underground sites, the Soviets installed forced ventilation systems powered by electric fans or diesel blowers. Ducts were cut through the rock to carry fresh air in and exhaust gases out. Some plants repurposed old mine shafts for this purpose, sealing them with reinforced caps when the risk of bombing raids was high. Lighting came from arrays of electric bulbs strung along the galleries, but electricity itself was a problem. Power grids were overloaded and fuel was scarce. At Chelyabinsk, engineers built local power substations fed by nearby hydroelectric plants and coal stations. In smaller underground sites, diesel generators were the rule, fed by tanks that had to be refilled constantly by truck. The low oxygen environment and exhaust fumes meant that many workers suffered headaches, nausea, and fatigue. Despite the harshness, the work went on 24 hours a day in 3 shifts.
Machine tools, the heart of any tank factory, required an extraordinary effort to install underground. Lathes, presses, milling machines, and welding rigs were heavy and delicate. Moving them down narrow mine corridors demanded custom-built cranes and rails. Soviet technicians used overhead gantries made of steel beams bolted into the rock ceiling. In some cases, they had to disassemble the tools, move them piece by piece, and then reassemble them underground. Precision was everything. A lathe misaligned by even a fraction of a millimeter could ruin a crankshaft. Engineers devised clever ways to calibrate machines without the benefit of stable concrete floors. They anchored them directly into the rock with steel bolts and adjusted alignment by hand. One engineer later recalled that the floor of his workshop was never level, only strong. Yet, despite this, tolerances on T-34 transmission gears and engine parts met wartime specifications. How did they manage to move tanks, enormous metal machines weighing up to 30 tons, in and out of partially underground plants? The Soviets adopted modular assembly. Hulls and turrets might be welded underground, while final assembly took place in nearby above-ground sheds. Internal rail spurs connected the two zones. Finished components traveled by narrow-gauge rail pushed by small locomotives through tunnels to surface finishing shops. There, cranes loaded them onto standard-gauge cars bound for final assembly or directly to the front. This dual-layer structure, production under earth, assembly on the surface, balanced protection with efficiency. The conditions for workers were brutal. The underground temperatures stayed around 10 to 12 degrees Celsius year-round, damp and cold. Steam condensed on the ceilings and dripped constantly. Many workshops had to be equipped with steam pipes to keep tools from freezing in winter. Lighting was weak, shadows everywhere, and the noise from grinders, forges, and compressors echoed painfully off the rock. Men and women, many of them evacuated families from western cities, labored side by side. There were no windows, little ventilation, and the ever-present smell of oil and sweat. But despite the conditions, productivity rose year after year. Soviet women became machinists, welders, and assemblers. Teenagers learned to operate presses. Entire families lived near the tunnel mouths in barracks, their lives dictated by the rhythms of the underground workshops. It was a community forged in necessity. Let's put this effort into numbers. By late 1942, the Soviet Union was producing more than 1,200 T-34 tanks per month. Chelyabinsk alone accounted for roughly 40% of Soviet heavy tank production during the war. Its buried elements, not fully subterranean but protected under reinforced structures and hillsides, included engine assembly shops and ammunition stores. The city of Sverdlovsk, modern-day Yekaterinburg, housed smaller, more specialized underground operations, factories making precision components, gun sights, and bearings. These were often located in reinforced quarries. At the Erlmash complex, several machine halls were literally embedded into the slope of a hill, with their rear walls cut directly from solid rock and their roofs covered by meters of concrete and earth. That combination allowed quick recovery after any air raid. If bombs destroyed the surface, the heart of the machine remained untouched. Another example of this hybrid concept can be found in the tank engine plant at Chkalov, modern-day Orenburg. There, engineers constructed semi-subterranean halls where the floor level was dug 3 to 5 meters below ground and the roof reinforced to withstand 500-kilogram bombs. These dug-in structures reduced the plant's visible height and thermal signature, making it harder to spot from the air. The Luftwaffe's reconnaissance flights, already limited in range by the Eastern Front's sheer distance, often failed to detect these camouflage sites. Where German photo interpreters expected large roofed buildings, they saw forest, hills, and barren ground. While beneath them, Soviet workers were shaping the steel of future T-34s and KV-1s.
The scale of labor involved was staggering. Soviet records show that more than 300,000 workers participated in factory evacuation and reconstruction projects between 1941 and 1942. Many of these also worked on underground fortifications or industrial shelters. Excavation was done almost entirely by hand or with primitive drills. Cement was mixed in barrels. Explosives helped clear hard rock, but every blast had to be controlled to avoid collapsing the mine galleries. The labor was dangerous. Roof falls, gas buildup, and tool accidents were common. Still, compared to the chaos of the front, the underground plants offered something precious: safety and food. It's worth comparing this to Germany's own later war efforts to move industry underground. When Allied bombers began devastating the Reich's industrial heartland in 1943-44, the Nazis turned to massive underground construction projects like Mittelwerk, where V-2 rockets were assembled under the Harz Mountains. The difference was philosophical as much as logistical. The German approach was centralized and megalomaniacal: vast tunnels, slave labor, monumental architecture. The Soviet approach was pragmatic and distributed: smaller, dispersed facilities designed to survive, not impress. In one sense, it mirrored Soviet military doctrine: decentralized resilience instead of showy gigantism. The result was less elegant, but more effective. By the time Germany started digging, the USSR had already been producing tanks from protected and concealed sites for over 2 years. The buried tank factories also reveal something profound about wartime innovation under duress. Necessity drove creativity. Engineers learned to solve problems in unconventional ways, using timber supports to hang wiring, rerouting water pipes through ventilation shafts, or improvising machine foundations from scrap metal and rock bolts.
The lessons learned underground fed directly into post-war Soviet industry. The experience of managing enclosed, high-humidity workshops led to better ventilation systems in peacetime plants. The practice of dispersing production units inspired Cold War strategies for hardening industry against nuclear attack. In other words, the buried tank factories of 1942 to 1945 were prototypes for a future in which survival itself was part of the design. But perhaps the most striking part of this story isn't technical at all. It's human. Consider the image of a young machinist, 19 years old, standing in the dim light of a tunnel, welding a tank hull that will be shipped to Stalingrad. Outside, the snow falls on a city that didn't exist 2 years ago. Inside, the air is hot and metallic. There is no sense of luxury or heroism, only the mechanical rhythm of labor, sparks, hammer, sweat, steel. And yet, these ordinary workers, buried beneath hills and forests, were the ones who kept the Red Army alive. Every tank that rolled out of those hidden workshops was a small victory not only over the Germans, but over the limits of human endurance and industrial possibility. By the end of the war, many of the underground factories were abandoned or converted back to mines. Their entrances were sealed, their histories forgotten. Some remain accessible today. Silent tunnels lined with rusted bolts, still bearing traces of oil and paint on the walls. Others were incorporated into Cold War-era bunkers and secret facilities, but their legacy endures. The story of how the Russians built a tank factory underground is more than a tale of engineering. It's a testament to the idea that in total war, survival depends not just on bravery or weapons, but on adaptability, the ability to build under the earth when the sky itself has become the enemy.